Since you had the pinning.
Yeah.
What would the outside be called?
Capsule.
Capsule. Then this is the. It's like in lots of organs.
Yeah, it's the.
The outer portion. It's always called the cortex.
Yes.
And then this would be the
Medulla.
And in the medulla we see the
Pyramid.
pyramids. Between them, which is sort of an extension of the cortex, I'd say, are the and they look like columns. Thank you. Now here's the pyramids. Now the urine's being made in the cortex and the medulla. By the time it gets to the tip here, the tip of the papilla, it is made. It doesn't change anymore. Okay. What's this first part here? Collecting system then.
I know it drains into the bigger one. I can't remember the name of it.
So you have what and what?
I can't remember the name of it.
Minor calyx.
Minor and major. That's right. It drains into the
And
major.
the major.
Yeah.
So minors drain into the major. The majors drain into the.
The duct, right?
No.
Oh.
Nope. For the ureter.
Pelvis.
Renal pelvis. Renal pelvis. That then drains into the.
Ureter.
Okay, ureter. Okay. So what else? So that's and then we had a renal artery going in, a renal vein coming out. Okay, so those are the things that you're pinned. Okay. Let's look at this. This is the beginning part. What is this called?
The corpuscle.
Corpuscle or
Corpuscle.
and this is also the capsule here or Bowman's capsule.
Mm-hmm.
Okay. And what would this be?
The vessel itself. The afferent.
Afferent what? Speak up, Michael.
Damn it, Michael.
Huh? Arterial. And then-
Afferent arterial.
Afferent arterial. What would this
Efferent.
be? Efferent what?
Ethereal.
Arterial. They're both arterials. That's important.
okay.
This is not a venial, okay? And what would this thing be here? You say a lot more here.
Mm-hmm.
This is the distal convoluted tubule. Some people might say the ascending loop of Henle, but it's right where the junction is. Okay, we're going to call it distal convoluted tubule.
This is convoluted.
And this is called the what?
Geomillers or
Glomerulus. I think that's what you meant to say.
How do you pronounce it?
Glomerulus.
Glomerulus.
Or glomerular capillaries. And we have a parietal layer, the Bowman's capsule, and this is the visceral layer, which is on top of the on top. Okay. So this is larger than this. The afferent's larger than the efferent. What does that do to the pressure here? Increases it. So that gives you a glomerular filtration pressure, pushing things out of the capillaries here. Yeah. So this and what's pushed out is called the filtrate, because we actually have a 3-stage filtration process. First of all, the wall of the capillaries filter out formed elements. Then I'm going to ask you to be kind of quiet over there. Okay? I'm going to ask you guys to be a little bit quiet. And then the basement membrane filters out
Protein? Large proteins?
large proteins. And then the filtration slits between the filtration slits of the podocytes, these are called podocytes, filter out formed elements, large proteins, now medium-sized proteins. So
Which does that? I'm sorry?
Medium-sized.
What does the medium size?
The filtration slits.
Okay.
So what we wind up with is a filtrate minus most of the proteins. Okay? But we still have things like glucose. We still have amino acids. We still have small proteins. We still have a lot of ions.
Ammonia.
All sorts of stuff. Okay? That comes later.
Oh.
And then this is going to be what? The beginning part of the...
This part right here.
Mm-hmm.
That's
It's near this, so it's called proximal. It's windy, so it's called convoluted
Tubule.
tubule. Proximal convoluted tubule, okay? And what are its characteristics? What kind of cells are these?
Oh. No idea.
Well, what do they look like? Yeah, simple cuboidal with lots of what on top?
Villi.
Microvilli, and inside lots of mitochondria. Because this is where we're going to do a lot of reabsorption. Okay, so let's move to something else. Okay, what do I want to move to? It's hard to say. You can do this, okay? So that's the proximal convoluted tubule. We're going to do lots of reabsorption. I'm trying to see, I think there's some things here. Yeah, it's kind of hard to see this. So what are we reabsorbing here? We're reabsorbing a lot of water, for one thing. Because we have about 1/5 to 1/4 of the blood supply, okay? Well, I don't know. It helps maybe a little bit, okay? And we're not using that sick one, wherever that is.
Which one?
The sick one. Let's see if they have this right. Oh, I'm not worrying about all the arteries, by the way. Just the afferent arterial and efferent arterial. And of course, this would be the renal artery, renal vein. Okay. So, in the proximal convoluted tubule, we're going to reabsorb a lot of water, and also we're going to reabsorb things, all the nutrients, because we don't want to lose nutrients like amino acids and glucose, and the small proteins. Also, you may reabsorb things, some sodium ions or other ions. Where sodium ions go, what follows it? Water. And that goes into what we call the peritubular capillaries that are peritubular around the the tubules. Okay, then we enter the loop of Henle, or nephron loop. In the descending limb, the thin portion has simple squamous. This is where we do a lot of osmosis. A lot of water leaves here. So the nutrients here went to the peritubular capillaries. Down here, we may have these looping capillaries called vasa recta. But a lot of water gets reabsorbed here. In the ascending limb, it varies. Sometimes it's all thick, sometimes it's thin and thick. Anyway, certainly in this thick portion, it's impermeable to water. But we're pumping out sodium and chloride ions into this area here in the medulla. That makes it very concentrated. That's what helps pull the water out. Okay. Then we have and that's with active transport. Then we have the distal convoluted tubule. That's especially important for secretion. Things like things containing nitrogen, ammonia, urea, creatine, hydrogen ions also, and variable amounts of water are reabsorbed, variable amounts of sodium are reabsorbed with the exchange for potassium ions. Okay, and this and also the collecting duct are under influence of two hormones. What are they? Vasopressin also has another name. Antidiuretic hormone. So that causes because that causes water to be reabsorbed. What happens to the blood volume if water is reabsorbed?
It increases.
Increases. What happens to blood pressure?
Decreases. No, increases. Increases. Yeah.
More.
Okay. Aldosterone is the other one, and that causes sodium to be reabsorbed in exchange for potassium. The sodium gets reabsorbed, again increasing blood, and water follows it, increasing blood volume, blood pressure. Okay. So whether or not those hormones are acting in the distal convoluted tubule and collecting duct depends upon how hydrated you are, basically. Okay. And let's see what else I was going to say. So a lot of secretion here, but some, it varies how much. Okay. Okay, let's see what else I wanted to say here. Okay, let's go back. Any questions there? Got that pretty under control? And let's go back to this area. What's this called?
The top part?
Or this area right here.
Let's see. Globulos? No.
Are you asking the type of cells there?
No, just the name of that little area right there. Very important for regulating things. It's called a juxtaglomerular. It's near the glomerulus.
JG cells.
Juxtaglomerular apparatus. See, JG, juxtaglomerular, near the glomerulus. And in the arteriole, especially, we have these modified smooth muscle cells. Okay. In the distal convoluted tubule, we have something called the macula densa cells. Okay. Macula densa kind of columnar type. And these are monitoring the blood volume and solid concentration. So if that drops too much, what happens is it causes these cells to release a substance, depending which book you read, enzyme or hormone, called renin. So we're just going to call it renin. We'll just call it renin and avoid it, okay? When renin's released, it causes all those changes. I gave you a big picture of it, right? It causes aldosterone to be released. It causes ADH to be released. It makes you thirst. All sorts of things happen so that you get more water in. You conserve much sodium. Blood pressure goes up. Blood volume goes up, okay? So that's very important. Now, counteracting it, we have something that's released from the heart that can lower the blood volume and blood pressure. That's atrial natriuretic peptide. Okay?
ANP.
So that's something released by the heart. Okay, so that's a pretty fast summary. As far as the cells, though, remember we have in the proximal convoluted tubule, we have a lot of simple cuboidal with lots of microvilli and lots of mitochondria because they're doing lots of reabsorption. In the descending limb of the loop of Henle, in the thin portion at least, simple squamous because we're doing lots of osmosis there, reabsorbing lots of water. And the thick portion, again, it's water impermeable. In the distal convoluted tubule, again, and collecting duct, again, we have cuboidal, but not as many microvilli or mitochondria, I don't think. Okay? There we go. That's it.